Good day, everyone, and welcome to today's DevOps.com webinar. We're excited that you've joined us. Our topic today is embracing DevSecOps with embedded application security. And today's webinar is sponsored by Contrast Security. My name is Mitch Ashley, and I'll serve as your host and moderator. A few housekeeping items. Following the webinar, we will send an email to all participants that has a link both to the recording and also to the slides. So you'll be able to get the information following the webinar. Also, we love questions. Our presenter today is going to be very interactive and we'll appreciate any and all questions. So please pop those into the questions tab of the GoToWebinar software. Just a heads up, we're going to divide the webinar today into two sections. First part will be about a 30-minute presentation, slides followed by some questions, and then we're going to get into an exciting hands-on lab. So get ready for that. I'm excited to see that happen too. So let's move into our topic, embracing DevSecOps with embedded application security. It's my great pleasure to introduce our speaker for today, Robert Statzinger. Now, Robert is Senior Solutions Architect with Contrast Security. All right, Robert, I'm handing the baton to you. Take it away.
Thank you very much, Mitch. And good morning, good afternoon, good evening, everyone. Thank you very much for your time today. I want to talk to you today about an approach for modernizing how you do application security that will keep pace with, the modern ways in which people do application development and deployment using DevOps. Now, I want to start with a little bit of a motivation about why this is important. Despite all the attempts that people currently do to secure their applications, the average application that is out there is still extremely vulnerable. If you look at some of the statistics out there, you see that on average, there's still about 26 vulnerabilities or more on average per application that are out there. And 73% of the applications out there still contain at least one of the OWASP top 10 vulnerabilities. Now, one of the things you need to be able to do is to focus your AppSec efforts on the places in which there are actually vulnerabilities. So you've got to be able to focus on the right areas of the custom code. And you've got to be able to separate the wheat from the chaff in terms of the open source libraries. Modern software is more and more dependent on open source software and libraries, but an awful lot of those libraries are not used, particularly when you take into account the dynamic behavior of applications as they run. So you have to be able to focus on those areas, both on the custom code and in the libraries where those vulnerabilities actually lie. If you can do that, you've already sort of gone very far towards accelerating in the efficiency and optimization of application security. Now, it's also no surprise to you out there, I'm sure, that we're all still under attack out there. You need only pick up the news, the Security Boulevard News, or other media sources to understand that the bad guys are out there and they are continuing to find the cracks in our software, the vulnerabilities that lie in our custom code and in our libraries. Now, if you look at the state of the practice that people have employed to date for application security, you kind of get a picture that looks like this. You get what we call this legacy tool quagmire. You have a set of disparate, static, disconnected tools that, taken together, are largely inaccurate and that provide a challenge in terms of staffing requirements to interpret all these results. So you have this logistical, disconnected solution that requires an awful lot of effort, an awful lot of staffing to man. And in the end, it doesn't really add as much value as the cost would seem to justify. So this situation leads to an impossible economic challenge. The needs of business today drive the need for more software faster, but you must protect the business. And there's no way that the budgets for security tools and specialized security staff are ever going to keep pace with the needs to develop and deploy more and more software. So you have this huge risk as the need to develop and deploy safe software far outpaces the budgets available for security tools and security staff. Finally, there's a technical challenge in protecting applications once they get into production. And now this is an actual sample of what happens if you go shopping out on GitHub for kits for bypassing web application firewalls. Those firewalls are out there on the front lines, and they are continually subject to attack, to high-speed fuzzing, to different ways that people find to bypass them with different methods. So this is just a couple of examples of what people have done. And as soon as somebody else finds a way around another firewall, up goes another kit on GitHub. So this poses a challenge to people who need to write and deploy safe software. Now, the root of the problem is the state of the practice for application security are based on a 15-year-old scan and perimeter-based software security model. This was built for the pre-DevOps, pre-cloud, pre-microservices era. So it's no wonder that it cannot keep pace with the needs of DevOps. Well, one way to think about how this could be resolved is to have application security seamlessly become a partner with DevOps. If you could fold application security seamlessly into the modernization of application development and deployment practices, you could develop a rapid security workflow that is repeatable from business to customer. You could ensure instant security feedback throughout your development organization, including both development and operations. And you could build a security culture that not only encourages experimentation, but provides those tight security feedback loops to make sure that the right people have the right information as soon as possible across the software development lifecycle. So the idea on how we can get there, the transformative idea here, is to embed application security into your applications themselves. And I want to talk about a platform that does exactly that. What Contrast Security does is we have agents that deploy sensors inside the application runtime environment. If you think about how the APM companies, such as AppDynamics, New Relic, Dynatrace, and so forth, have been successful, is with this dynamic instrumentation approach. We've taken that approach and we've used it for application security instead. So these agents deposit little sensor points that understand and monitor continuously the HTTP parameters and cookies, the custom code, the data flow, the control flow, the open source libraries, even the runtime environment. So in development and test, this platform embodies interactive application security testing. This approach detects vulnerabilities 24/7 in a continuous mode in both custom code and libraries during normal use of the application. And the way it does this is by examining the routes that usage of the application takes. And these routes are the pathways that login requests, search requests, and so forth take through the application. And IAST essentially says, all right, this route needs to prove to me that it is safe. This route needs to prove that it is defensively coded, that it is ensuring that data is sanitized, validated, and encoded, and so forth. And if that route is not encoded, and if it is heading for a vulnerable endpoint or back end of the application, then we raise and confirm a vulnerability. Now, what's nice here is that this tends to minimize false positives and improve accuracy because we've directly observed this vulnerability manifest. And we have code-level diagnostic information down to the line level for specific code modules. In production, this same platform becomes a runtime application self-protection mechanism. In this mode, the agent starts to look for malicious input. It knows the difference between normal application usage and malicious attempts to exploit the application or change its intended functionality. Now, this is really important because, again, we have all of this diagnostic proof inside the application as it executes. So if there is malicious input heading towards a vulnerable method or a vulnerable endpoint, then we declare an attack. Moreover, the agent can raise an exception at runtime and block such an attack. Now, if you think for a minute about how a web application firewall works, the web application firewall is sitting out here outside the application. It has to make a decision right here about whether or not some signature-based attack is something it needs to handle. It does not have access to all this internal diagnostic information that a RASP does. So a RASP can be a lot more accurate and provide a lot more fine-grained diagnostic detail. It also decides whether or not this is something it needs to block right before the exploit happens, when it has all of this evidence of attack. So some wonderful things happen when you embed AppSec inside your applications. What it means is AppSec deploys with your application. So you no longer have to care how you deploy things, right? Whether you deploy using your IDE, whether it onboards with Jenkins or Circle CI, whether you're using Chef, Ansible or Puppet or any of the other package management tools, your idiomatic platform-specific package management, Docker, Kubernetes, however you deploy and run your application, your AppSec is right there with you all the way across the application development lifecycle. So this provides a frictionless, continuous, unified approach for application security across the lifecycle. In development, what it means is that your developers, as they work, as they write and test software, get instant feedback in their IDEs, in their chat ops, their interactions with GitHub, right? They are empowered to master application security and treat these always-on discovered vulnerabilities as bugs. Pop them into Jira, they're handled just like any other bug, right? Developers are armed with this always-on 24/7 vulnerability discovery engine that empowers them to check in cleaner code at the very beginning of the application development lifecycle. When you get to the CI/CD QA stage of things, this is great because now you have that assurance that you're going to release a quality build that passes muster from an AppSec security. So some nice things happen when you directly integrate with your Mavens, your testing tools, your Selenium tools, when you directly empower Jenkins and so forth to use embedded application security as a quality gate every time you do a build. And notice something else here about testing. This is really important. I'm going to touch on this again. Interactive application security testing means that all of your manual interactions in the UI, all of your Selenium tests, all of your functional tests, all of your QA regression tests automatically double in value as security tests because they are exercising all of those roots in the application. So your coverage during all of your testing is doubled in value. And when an application moves to production, you want that rapid feedback through your operations incident management tools, your analytics such as Splunk, your VictorOps and PagerDuties, to make sure that you are informed of attacks, but not just any attack, successful attacks, distinguishing between attacks that cannot succeed from attacks that will succeed, and making dynamic decisions as the application runs about how to block them. And this approach has tangible business benefits. And we have the proof here. We have customers such as a top 3 software and IT company who now secure over 1,400 of their applications with less than one full-time extra headcount. They don't use their own internal static application security testing solution anymore. They have partnered with us to protect all of their crucial applications. Game-changing economics for a Fortune 10 financial services company who have seen a 50% reduction in pen testing costs because embedded application security continuously finds the problems, the vulnerabilities, and so forth, and gives the pen testers a head start on exactly where they should be looking for problems. Embedded AppSec accelerates the software development lifecycle. So a top 3 global insurance company saw a threefold increase in the release of safe software, rapid innovation that also protects the integrity of the business. And enhanced security, where a major healthcare company is protected to the tune of 2.2 million application layer attacks every month. So it is possible then to do DevOps and AppSec at scale. This is what happens when you embed application security into your application runtime environments themselves. You have the ability to deploy IAST and RASP agents in parallel across your entire application portfolio, whether they're in development, QA, test, CI/CD, or production. You get this continuous assessment and protection in parallel across your application portfolio and across the application lifecycle. Now, this is a depiction of how one way to onboard IAST and RASP. It's as easy as downloading an agent. You can see currently the languages that we happen to support. Install the agent, restart an application server environment, and start collecting security telemetry as your applications are used. Now, I do want to mention the free DevSecOps tools that we know about out there right now. I've been discussing a little bit about the Contrast Community Edition, and if you want to stay tuned for part 2, you're going to have the opportunity to sign up for the free Community Edition and walk through a lab to see for yourself the power of embedded AppSec. But there are also OWASP dependency check tools as well as retire.js that can help jumpstart you for free to merge application security seamlessly into your existing processes. So that concludes a brief presentation here. Are there any questions, Mitch, that I should be addressing?
Yeah, we do. Appreciate the questions from our audience. First of all, how does your solution, I think they're talking about your product, how does your solution differ from static application security testing approaches?
So that's a great question. And the primary difference is a static application security testing tool is sort of like a point-in-time scan of a body of code, right? It doesn't know anything about the dynamic behavior of the application as the application runs because it does not work as an application runs. It works by essentially calling timeout on constant development and testing efforts and saying to the application developers and the DevOps people, all right, it's time to scan the code. And typically the output of such an effort is a long list of vulnerabilities that are dumped on someone's desk for them to try to decide how to handle. So it's disruptive, it takes time, it's discontinuous, and frankly, it's full of false positives. If you compare that to an embedded AppSec approach where as you work, as you develop and test, you naturally discover vulnerabilities 24/7. You get those results instantaneously in an IDE plugin that coaches you on where exactly you should be writing cleaner code and how to do it. You're going to see a vastly accelerated cycle of vulnerability remediation across the application development lifecycle.
Excellent.
Any other
Very
questions?
good. Yeah, so we've got a couple more. So Another question is, do we need to do some sort of configuration of the agents to understand the application functionality and any possible attacks? I think you talked about kind of telemetry and configuration.
Mm. Generally, there's a default configuration for agents that works for most applications. There are, of course, a number of different options and flags that you can pass to the agents, but basically, you simply download the agent and then you embed the call in your infrastructure management scripting, however you start your applications, and you simply restart and go. There are, of course, a number of different options that you can pass, but the default set of options is quite suitable for most applications. Now, if the question is around changing builds or changing source code or recompiling, that's never necessary.
Okay, great. That's good to hear. If a customer has an IAST or RASP agent already deployed, and when they want to go for external pen testing from, say, another third-party vendor, will the payloads and requests, the malicious attacks in this case, be blocked? How does that work?
Yeah, the agent works by default by notifying you of attacks. And you'll see during the laboratory that by default, we're going to tell you about attacks until you get comfortable with the solution. And then there's just a dynamic switch you set in the contrast user interface that changes the agent's mode from monitor to block for particular attack types.
Okay, very good. How about tickets being raised automatically to notify you when there's vulnerabilities that need to be remediated or are open to attack?
It's a great question. And we, for example, have full two-way integration with Jira. So again, code level vulnerabilities get popped onto the Jira stack just like any other bug, empowering developers to treat AppSec issues in the code like any other bug. And when you change the status of an incident or ticket in Jira, it can propagate back into contrast and modify the state of that vulnerability to mark it as fixed or remediated.
Okay, very good. How do you handle software licensing across dev, QA, and production? How does that work?
So there's a few ways to answer that question. And the way we license our product is in two different ways. We license by application in the IAST mode, meaning, for example, per application, per monitored unit. Typically in a Java JVM, that's one application, but it might be a handful of applications served out of, let's say, a J2EE environment. When you talk about microservices, there's a ratio that we can employ to sort of license based on some number of microservices. We also factor in the number of developers as sort of a guideline for how we license. In production, when we're talking about RASP, it's licensed based on the number of runtime instances, meaning .NET instances, individual running JVMs, and so forth. Now, when we're talking about licensing that our customers are concerned about, there's another feature here that I should discuss. When we handle the risk of assessing the risk of open source software, we can provide the licensing information for public open source libraries. So an example here is, let's say a customer organization is not allowed to use GPL-based licensing. If any of their applications are using libraries that use that or any other disallowed licensing scheme, they can be informed of that. So we help our customers maintain licensing compliance for their use of open source software.
Okay, good. We've sure generated a lot of interest. I got some more questions if you're ready to keep going for a few.
Sure.
Next, I have a couple of questions I can kind of combine around scalability and of contrast, and also is there any kind of performance hit or impact issue doing the testing?
Great question. So, so we run our service, it's available as either SaaS or as on-premise. And in one instance of our server, you can have up to, several hundred. I've seen 200 to 300 applications sort of collectively monitored by one example organization. And that's kind of nice because it gives you the ability to sort of holistically protect, 200 to 300 applications. And it gives you the ability to see organizational KPIs, trend analysis on vulnerabilities and attacks, and also some KPIs on the average time it's taking your organization to fix vulnerabilities. So you track that on the main page. Now, in terms of scalability, in terms of onboarding scalability, it's all in parallel, right? However you deploy and start up your applications, whether it's Docker, it's Kubernetes, it's NPM, it's NuGet, we're right there with you. So the parallelism of onboarding applications is seamless, and there's no friction points there. What was the second part of that question, Mitch?
Talking about both the scalability, but also is there a performance hit at all? So those are the two parts of the question.
So the agent runs in a couple different modes, right? It runs in this IAST mode in pre-production. And in that mode, we're always on a curve between diagnostic depth and overhead, right? So we've minimized the overhead for both of the products, but we allow a little bit more overhead in pre-production because we want detailed, path analytics, path flow analytics, data flow analytics when we're discovering vulnerabilities. In production, the agent runs in a very different mode where the overhead is extremely minimal. And I benchmarked this with customers where the difference between running contrast in RASP mode and not running contrast at all is minimal. So in production, our customers find minimal intrusion.
Okay.
And in pre-production, I'll make one more comment on that. In pre-production and in development and test, developers are typically running debuggers, tracers, profilers, and so forth. And the reason they do that is for diagnostic depth, right? So we take the same approach. We want to maximize diagnostic depth, vulnerability discovery, and the speed of vulnerability remediation at the expense of a little bit more overhead during development and test, which goes away when you use this in production.
Okay, very good. I'd like to take maybe just a couple more minutes for some remaining questions, and we can get to the lab.
Sure. Okay.
How does IAST detect vulnerabilities? Assuming that the tests that you're running in QA probably don't have the vulnerabilities in them, but how do you detect it?
Okay, so that's a great question. Remember, the vulnerability is not necessarily in the test. The vulnerability is in the code that is being tested. The agent does dynamic bytecode instrumentation, and that means it deposits in runtime some hooks that call into our agent libraries. Now, the intellectual property in our agent libraries knows how to assess the safety of that root. It knows how to assess whether or not that root is properly sanitizing, validating data, ensuring that the data is encoded, and so forth. So the hooks that call into our agent libraries, those agent libraries have the task of determining how defensively coded those roots are. Okay. Now, what's important about the QA tests is that they exercise those roots. Okay, so that's really important. Those vulnerabilities are lurking there, undiscovered in the code, undiscovered in those open source libraries. And by the way, we list all those CVEs. So what we're doing is telling you this test ran along this route, which exposed this vulnerability in your custom code, and then called up these 3 or 4 libraries, and here's the code that ran in those libraries.
Okay, very good. One last question, I'll kind of combine a couple. Do you need access to source code or to the JVM, or is it all of this handled through the libraries that you were talking about?
We don't need access to the source code. You take, for Java, for example, you take our jar file and you attach it as the JVM starts up using the Java agent flag. And all the other platforms we support have equivalent mechanisms for performing dynamic instrumentation. All right, so we never touch application source code. We onboard in the application through instrumentation methods dynamically when the application starts up.
Okay, very good. Well, that kind of wraps up the questions, man. I think we've got a really sharp audience today. Those are great questions. So I'll turn it back over to you. Let's move on to the hands-on lab.
Thank you very much. I just want to put up a very brief slide about who we are and how we got to where we are. Investors and the industry think very highly of us. We do have over 200 customers right now. We have 119 million in total funding. Forbes this year put us on their next $1 billion startup list. We have a great pedigree. We're growing. We have a global presence, and we'd love to show you how it is we do what we do. If you guys out there have Docker, you're gonna have the opportunity here to jumpstart this DevSecOps process for free using our community edition. So if you're out there and you're able to follow along, so here's the first thing I'd like you to do is to just grab my repo, clone this guy or grab all the files, stash it in a working directory. This repo has a lab guide, a Docker file, and a couple of scripts for you. And if you can grab that stuff, throw it somewhere locally for yourself. I'll leave this slide up for another moment just so you can grab that URL. And if one of the proctors can put this GitHub URL in the meeting chat, that would be excellent. Is that something you guys can do? Thank you very much. I will try to go slowly here, but once you have that repo, grab it, clone it, grab the files, sign up for a community edition account here. So this is a free version of the Contrast IAST and RASP solution. It's free for one application. It will get you started here. We're going to ask you to fill out a little information. You will need to use a corporate email address. And you will want to get a confirmation email. And that can take a couple minutes. This link should also be in the meeting chat for you. I want to make sure that you do it. So typically it will take 5 minutes or so, a little bit more, to get this email back to you. But I hope some of you out there will be able to follow along and pursue this. Maybe I'll ask you to raise your hand in the meeting or post in the chat if you're able to start doing the lab with me. I'd like to get sort of a rough feel for how many of you are this is going to be really easy. You're going to clone that repo. You're going to sign up here. You're going to plug some tokens into a Docker file, and you're up and running. So while you're doing this registration process, I want to make a brief soapbox here. You know, when we talk about DevOps and this sort of continuous process, the evolution of software development and deployment, one of the things that sometimes gets left behind is this notion of continuous testing. The more rapidly you're going to develop and deploy software, the more important it is for you to test. Okay? Always be testing. Test in development, in deployment, in production, functionally test, acceptance test, QA regressions test. Always be testing your software. And if you didn't think about where you can test, well, where can't you test, right? Across the application life cycle, as you develop, as you plan, as you merge, as you build, as you release, as you monitor, always test. And the good news is IAST and RASP double the value of all these interactions, okay? Every test you run, every manual interaction, every QA regression test, every Selenium script is multiplied in value when you do IAST, because all of these will exercise roots. You can think of this as doubling the code coverage, right? Now, your code coverage is doubled in value. And it just basically functionally testing the application is going to get you most of the way there. So how are we doing here? I have a more detailed walkthrough of the sign-up process that I can step you through now if you like. So you're gonna be faced with a page like this. You're gonna create your free account. You're gonna give some information here. The only thing that needs to be accurate here really is your work email address. So give us all this great information. Tell us that make yourself a great title, and then get this nice confirmation email. Hopefully, it won't take you too long. When you get your email, all you'll need to do is click a link in it. The email will look like this with your email address, which is your username. And you'll click confirm account, and then you'll have an opportunity to set your password. Can I get a feel in the chat window for how many people are doing this? Avi, is that something you can see?
Let me check. It's probably better to just keep going.
Keep going? Okay. So once you confirm the account, you're going to have the opportunity to set your password, agree to terms and conditions. You're going to get greeted on the screen by us, and you'll have the opportunity to get started. We know who you are. You're going to be given an organization, which is like a tenant in our Community Edition world. You're walled off from anybody else who's running Community Edition. You're the administrator of an organization. And after you agree to the terms and the conditions, you can get started. What I'll want you to do here is click Start Agent Setup, because we are going to onboard an application for you using Docker. So click Start Agent Setup, and then dispatch this window. This is a good wizard for you. Remember, you can only onboard one application, but I'm going to ask you to dismiss this because we're going to onboard directly using Docker. So click that red X, that X you're going to see at the top right, and get to your starting point page. And in your starting point page, under your name, you will find your account. And the Your Account page contains the tokens that you can set in Docker files, in environment variables, and so forth. Now, in the organization page here, you're going to grab, in the Your Account page, you're going to grab the organization keys, the organization ID, the API key, and the authorization header, and then you're going to stick them into your Docker file. Now, I know this is not best practice, but we want to be expedient here. So these keys are the key to automation. You can stick them in environment variables. They can be secrets for you in all of your scripting capabilities, but these are the goods, right? They're private to you, they're personal to you. So grab the organization ID, the API key, and copy the authorization header and stick them into that Docker file of yours. Let me go back to that main presentation. So once you get these keys, plug the organization ID into the Docker file, plug the authorization header into the Docker file, and the API key into your Docker file. Double check for correctness, and you're good to go. That's it. The rubber's going to meet the road as soon as you're able to complete this. Okay. All right. Now, all you have to do is run 2 Docker commands. Okay? Build your container and run your image. Now, I'd like to have a show of hands here. How many people are going to be looking at this screen here in my demonstration? I'm going to switch live to my laptop and do this myself. I would never ask you to do something that I'm not willing to do myself. So here's my Docker environment. Okay? I'm going to run the build script, but I've already run this before, and I'm going to run the run script. It's going to start up my container. And here we go. I now have my Contrast Community Edition site. I have my WebGoat UI, and I also have this lab guide. So this PDF is something you hopefully downloaded from my repository. If you didn't do so, please do so now. It's going to guide you through some hands-on lab work with this exact setup. This laboratory will walk you through a few basic use cases for interactive application security testing, as well as runtime application self-protection. Along the way, it will introduce you to how Contrast can separately assess your risk of using open source software. Okay? Once you get to this point, you should be good to go. The only other things I'll point out are at the very end of the lab. If you need more help, you can, first of all, you can always contact me. You can always look at the integrations. You can look at our product documentation. And you can look at our blog sites as well. So let's do one simple lab here, okay? I'm going to log in as my guest account here. Now you can see right now my vulnerabilities, I don't really think there's much there. So let's do something like this. Let's go down here to parameter tampering, okay? I think maybe that. What I'll do is I'll show you that vulnerabilities are persisted but repeatable, right? So I'm going to assume I've just onboarded this application for the first time. If I go into my friend WebGoat here and I go to parameter tampering, now what's important to note here is there's nothing I have to code up special, right? If I want to examine how we discover XSEs, I can type anything I want here, right? Remember, it's about the vulnerability of the pathway. It's about a vulnerable pathway that is not protecting this information, okay? So Contrast automatically detected the fact that that simple interaction in the user interface of the product exposed a vulnerable root for cross-site scripting. If I drill into that result, I'm going to get a full story on exactly what happened here, okay? There was a post for a cross-site scripting attack here, a vulnerability that happened because we did not properly sanitize the data. Here is all of the incoming HTTP information, the parameters, the cookies. I have a little postman-like UI here if I want to replay that attack, change the parameters and so forth. I have all the code level details, meaning I have that full stack trace. Remember, there's no substitute for being inside the application. You get all of this line level code forensics. And because the founders of our company, one of the founders of our company is a guy named Jeff Williams, who was one of the founders of OWASP. We have tremendous subject matter expertise in this organization. So every finding is going to come with code level coaching advice on what to do differently in order to not have this vulnerability. Now, when you graduate to a more full deployment of Contrast and you're using an IDE plugin, this kind of use case can be executed fully from within the IDE. So within 10 or 15 minutes, you can be developing code, testing a feature, seeing the results of a vulnerability in the IDE plugin, and fixing and checking in cleaner code. Imagine how much time that is going to save you. Now, let's go back and do one more vulnerability. So I'm going to go up to my injection flaws. And I'm going to take a look at string SQL injections. All right, so if I'm just going to do a simple search here. Okay. I'm not doing anything malicious. I'm going to do it just, okay, there's Smith. I tested that feature. The feature works. Imagine I'm developing this feature right now, and I just tested it. Well, that's great. The feature works, but guess what? We have exposed a vulnerability in a pathway, okay? What happened is that pathway is vulnerable. That pathway did not ensure that the data was encrypted, that the data was encoded, that the data was validated, that the data was sanitized. So here's, again, a high-level risk-oriented discussion. Here's the HTTP parameter information. Here is code level details down to the line of code. And in this instance, it's kind of easy to see what happened, right? We had this monolithic string query in Java. We didn't use any name parameters. We didn't use any bind values, And again, in the how to fix, we're coaching developers at the left end of the application development lifecycle on how to check in cleaner code. Okay? And there's 2 more labs here, or 3 more labs in this document that will walk you through how to detect and block attacks. We'll show you how to show you how to look at the library results. We should probably do that very quickly. Remember, independently of all this, we are showing you how you can assess the risk of using open source software. Okay. This WebGoat application uses 84 different libraries, of which 18 are vulnerable, meaning they have open CVEs. I can see what all the CVEs are and how bad they are. I can also see how out of date my current library usage is. For Spring Web 3.2.4, notice that I'm using a version of this library that's 6 years out of date. I could probably knock off a bunch of these CVEs if I was only going to upgrade to the latest version. Notice also that we are keeping a running tally of the amount of code from each library that you're actually using. Now, as the application runs and is exercised and used, this class count will increase because, after all, as different pieces of the application are used, different code from different libraries is called up into action. But what this is a measure of how much usage this library is currently getting. I mean, the H2-1.4 library is using nearly half of its classes right now. The Spring Web MVC library is using about 13, but there's 7 CVEs. So overall, this is a way for you to assess the risk of using open source software. You have 23 libraries that are 3 years behind. You have 4 years behind for 15 libraries, and so forth. So this is, at a glance, determination of the risk of using open source software. Okay, I think we have about 10 minutes left. I want to stop and take questions. I hope you've all found this useful. I want to encourage you to learn more about embedded AppSec. I want to encourage you to learn more about IAST and RASP. And yes, I want to encourage you to learn more about contrast security. Mitch, guys, how are we doing on questions? How are we doing?
We've been answering some questions, doing some questions
Excellent.
along the way that folks have entered. So I think we've caught up on most of those. So a lot of good feedback too about it's a great example to start out with.
Great. Anybody hopelessly stuck?
You haven't seen an SOS sign yet.
Okay. All right. Good to know.
I think you're doing well. Helping folks keep along, and the team behind the scenes is helping too. So I think we're in good shape, Robert.
Thank you very much. I think that concludes what I wanted to, my goals for today. I want to thank you all for your time and your attention today, once again. I want to remind you all of the location of the repo. I will be providing PDFs of the slides I used during the presentation later this afternoon. I'll get them into the hands of the moderators of this meeting. And thank you all very much once again for your time today.
Great. Well, thank you. That was an amazing presentation and great lab. I think folks learned a lot. I certainly did. Thank you, Robert. And thank you, everyone, for your participation and questions during the webinar. Just a reminder that we are sending out the slides and a recording. It's available via an email with links. We'll also have it up on DevOps.com. And remember to check out the website, DevOps.com, to find out other more exciting webinars. And of course, checking out Contrast Security's website as well. But joining me in thanking our speaker today, Robert Satzinger, Senior Solutions Architect with Contrast Security. And I'd especially like to thank you, our audience. We've spent some valuable time with us, and we appreciate you doing that. It's been my pleasure to be your host and moderator. Have a great day. Be careful out there.